All right, welcome everybody to the third session of the gentle introduction to functional JavaScript as my phone starts ringing. Wonderful timing there. I do want to say real quick, thank you once again to Chet Harrison for being here with us today. Chet has done a phenomenal job of opening my eyes to the world of functional programming and really helping me see how simple some of these concepts really are, in spite of the years of me trying to wrap my head around this stuff, with currying, with monads, with composition, with the way you walked us through validation in the last session. That was great to see, and I'm really, quite frankly, excited to see where we're going to go today with functional reactive programming and the ability to handle asynchronous code in our functional JavaScript. So with that being said, take it away, Chet. Lead us down the path and get us some more amazing knowledge.
Okay, all right, I hope so. So today's topic, FRP, or functional reactive programming, is really, under the covers, this is a monad. It's one of the most powerful monads I've come across. One of the most compelling reasons to dive into functional programming. And like most things functional, you don't really have to understand all the mathiness behind it. It helps to have a common sort of language. And often in my functional adventures, I find the same concept being called several different things, and it leads to a lot of confusion, especially when you're getting started. So I'm going to try to touch on just a few bits of terminology as we go down the path, and I might reiterate just for, just to reinforce these things. I'm going to touch on a couple simple patterns over and over again throughout the talk, because I think that'll give you what you need to really kind of take advantage of this stuff. So being that this monad is so spectacular, I think it deserves a little bit of a history to it. But as Derek rightly advised me the last talk, I think it's always good to start off with a little dessert. So
yes,
I whipped up a little example of what you can do. So this type of monad is called the observable, and it is a kind of a subclass of a monad called the continuation monad. So this is an example. It's very good at handling all things asynchronous and concurrent, and those are two of the hardest to really master, I found, in programming. So in this example, what we're going to do, we're going to take a stream. A stream is a collection, like an array, that arrives over time. In this case, the stream is going to be mouse moved events, and we are going to take that stream of events and add some behavior to it.
Nice.
And you see the...
Yeah, I see the time flies like an arrow following your mouse cursor around.
There you go. Okay.
That's fun.
Fun. Simple.
But this is being done using functional programming and this observable monad? Yes,
exactly. And this is taken directly from the Reactive extensions repo. There's a folder in there with a bunch of examples, and it covers a bunch of asynchronous topics like autocomplete boxes and
is that linked from our repository?
Yeah, in our repo.
I'll paste that link into the chat real quick for those that are live with us.
Bump up the font here.
There we go.
So under Reactive extensions, that's the name of the library. There is a link that says examples right here. And if we click it, it will take you to...
Nice. A lot of different examples.
A lot of different things. You even got some nifty D3 stuff.
Excellent.
It's a pretty...
Yeah, back to the observables in that demo that you were showing us. Let's dig into some code on that. I want to see what's happening behind the scenes and how these monads are working to make this happen.
Okay. So when you typically approach these things, you'll start off with a bunch of helper functions. So this function right here is what is going to be used to move around the various letters in our little sprite. And then here we've got, the text. You can change this to watch me code. And then we're going to grab some elements. And here is where we're going to get our mouse move stream. Okay.
Okay.
So Rx exports an Rx namespace, capital R, lowercase x. We're grabbing an observable instance, or I should say a factory, and we're going to adapt the event API to an observable API. And this is kind of an interesting concept to point out, because in a lot of asynchronous code, like set timeout or clear timeout, you've got add event listener and remove event listener. They are arguably doing the same thing. You're subscribing and unsubscribing, but everyone's got a different name for what they're doing. So the first thing that you want to do is look at all APIs that are asynchronous and try to adapt them into an observable. And then you've got one API with a bunch of operators that you can use on it consistently.
Right.
And it's sort of like the API to rule them all, and you can get, the more you use these particular methods and operators, the more comfortable you get with that way of expressing yourself, and you don't have to learn 1,000 different ways to do the same thing.
Right. So you're creating an adapter basically around all of these different, events or whatever they happen to be, in order to create a consistent API that you can work with in a consistent manner.
Yeah, exactly.
Nice.
And that, if you're just using the same 12 operators over and over again, eventually you're going to get pretty darn good at it, right?
Yeah, yeah.
So, and that's exactly what Netflix did when they did their big redo of their website and all their different services. Is according to Jafar Hussain, who's their technical lead, they looked around their entire front-end code base, even some of the back end, and looked for all things asynchronous, and they figured out how to adapt it into observables. And everyone just got really good at working with the observable.
Nice.
So if, for example, if you want to look at, just to jump out of this for a second, to kind of prove the point. Oh, wait a second. Here we go. No, that's not it. Where did it go? Okay. Yeah, okay. Here we go. So, here what we're doing is we're going to adapt a timeout API. Okay. So you've got set timeout. That's the way you sort of subscribe. And here we've got clear timeout. Okay. And we'll get into the guts of this in a second, but I just want to kind of make this point. Here, we're going to adapt a DOM event. We've got add event listener. We've got remove event listener. Here, we're going to adapt a jQuery get JSON. And you've got, the get JSON, and you've got the XHR of boards, or we're calling it XHR, but it's, you've got, this is the way you unhook or cancel.
Right.
So the concept being is that we've got three different things that are essentially doing the same thing, but we can adapt them into observables and use the same language, the same API. So let's jump back up to the top here so I can keep my train of thought. There's a lot of nasty bugs that are associated with concurrency and async. If you have a bug that you can't consistently reproduce, typically you have shared mutable state, and you can get rid of that by using an observable. Another class of bugs is you have a memory leak because you forgot to unsubscribe from an event listener.
Constantly. It's like the number one cause of memory leaks in object-oriented programming is event handlers sticking around forever.
Exactly. So the observables, one of the interesting things that I came across while I was preparing for the talk is if you go back to the Gang of Fours Design Patterns book, and you look up the iterator pattern on page 257, it says, quote, "The key idea in this pattern is to take the responsibility for access and traversal out of the list object and put it into an iterator object."
Right.
So the key word being responsibility. Now, just to cover this pattern, okay, essentially what you want to do is have you have a list, an array, call it, some kind of thing that you can iterate over, and you can call it and request an iterator object. And that object has a next method on it. Right. The next method is responsible for giving you the next value as you traverse the list.
Right.
Okay. So the interesting word here is responsibility in this quote. The responsibility for unhooking your event handler is in the wrong place in DOM event APIs.
Yes.
You've got a consumer and you've got a producer. Okay. And the consumer should not be responsible for unhooking the event handler. The producer should be. Okay. And the consumer should have the ability to say, hey, I don't want any more data, but it should be the producer's responsibility. And once you kind of make that mental flip in using an observable is essentially an inverted iterator. Okay. So in the iterator, it's a poll pattern, right? You request this iterator object from your list.
Right.
And then you say, give me a value. Give me the next value. Okay. With an observable, what happens is you subscribe, you as the consumer go to the observable, which is the producer, and you say, look, here's a subscription. Okay. And when I call subscribe on this observable, I'm going to pass in 3 callbacks: on next, on air, and on complete. All right.
Okay.
And when the producer has some interesting data to pass me, it's going to call one of those 3 things. Right. But it knows when it's done producing information how to clean up. It's got a disposable method on it. So let's see what that looks like. Just had a really good one right here. Oh, well, first, let's look at the iterable, okay? Here it is in concept. We've got an iterable, which is this list of 1, 2, 3,
yep,
an array. And this is ES6, by the way. Here's how you would get the iterator object, kind of a strange looking syntax, but that will return an iterator object. And here is me calling iterator next, iterator next, iterator next. So let's see what this looks like when we run it. So we get 2 values back. We get this sort of, are we done? False. And then here's the value. Here's the second on next call. Are we done? False. Here's the value. And then when we are done, this is going to turn to true. Your value will be undefined. This is, going to be returned every time we call on next.
Right. Okay.
Now, this is an example of, let's see. This is probably not the best place to start. Okay. Yeah. All right. So this right here is a classic observer object. Okay. It's an object, literal, and it's got 3 functions or methods. You've got on next, on air, and on complete. Okay. Now this is where you kind of customize your callback behavior to do whatever you really want it to do. And when we are trying to create an observable, this is like an observable from scratch. Okay. So we're not even pulling in reactive extensions at this point. We're just writing from scratch. So This is how simple this code really is. Okay. In this particular instance right here, we are trying to create an observable for a timeout. Okay. So what we're doing is we're creating an observable here by passing in this guy right here.
Oh, yeah, it's starting to make sense. You're creating functions. You're ending up with a function that takes an observer object, which you have just above, and the observer has the on next, on error, on complete. And then with your timeout observable, the set timeout happens to be the function, the callback function in the set timeout happens to be the thing that calls on next and on complete, because there's only one thing to do. There's only the one timeout. It's not something that's looping.
Yeah, and let's touch on that too. Okay, so the interesting thing about lists and why functional programmers love them is that lists can be empty. They can store one thing or they can store many things, right? And
right.
It may be a chunkier data type, but again, you get to use this sort of consistent API when dealing with lists, regardless of what's inside them, right?
Yeah.
So it's kind of a nifty little trick. But there's a little bit more than just observers going on in this. This is called a subscription function, okay? So an observable, I'm going to say this over and over, an observable takes a subscription function, and when you call that observable, you say observable.subscribe, you are going to pass in an observer.
Right.
Observer has what to do, wrapped up in these callbacks, okay?
Right.
The subscribe function will return a disposable, okay?
Okay.
This is an object that's got one function called dispose, and it knows how to clean up.
Nice.
Okay? We'll see this over and over again. So in this, right here, this knows how to call the set timeout and what to do with the data that comes out of it, right? So when this is, what to do, we're going to call the observer that we passed in right here, and we're going to on next it, and we're just going to send it next, right? So if this was the observer that we passed in, it's just going to log it to the console.
Right.
Okay. In this particular instance right here, we're adapting a DOM event into an observable, right? So what we do is we get, the guts of what we need to get our job done. And then we create an object with a subscribe function, okay? This is what's returned. The subscribe function takes an observer and returns an object with a dispose method, okay? And that knows how to clean up. Here we're doing the same thing. We are creating an observable by returning an object that has a subscribe function, and it knows what to do. It takes an observer and it returns a dispose method in an object.
This is honestly starting to remind me a little bit of promises.
Yeah, exactly. Because promises are monads.
Oh, really?
It's a monad. The reason why observables are more powerful than promises is a promise is like a single element of an array. An observable is like an array. And the beauty of a observable is look what you can do, right? With a promise, once you set up your promise, you have no way of aborting it.
Right.
It's out there in the wild doing its thing, and there's no way to stop it.
Yeah, there's a bunch of recommendations and enhancement ideas for making promises cancelable in a future version of JavaScript, but it's not there now, and it's not an easy problem to solve from some of the specs that I've looked at. Yeah.
And so the observable is a more powerful way of doing asynchronous calls. And this is just one of the major benefits of it. So let me get back to my repo and stay on track here. Okay. So again, we put the responsibility for disposal in the producer's hands.
Right.
Okay. All right. So the observable represents a single universal composable API.
Right.
And that allows you to work with events, network requests, timeouts and intervals, promises, even synchronous collections like arrays and strings, and then tasks monads like promises or futures, that sort of thing.
Mm-hmm.
So in the front end, that means you can use them to build animations, application initialization, data access, view model bindings. They're all over the place once you really kind of think about it and dig in. Okay. So to kind of get into the ramp up as to how we got to observables, I kind of cooked up a little metaphor. We say, suppose your house catches on fire.
Mm-hmm.
You call the fire department, and then you pick up a fire extinguisher and put the fire out yourself.
Right.
When the fire truck arrives, you have no need for their services because the environment being the keyword, has changed. So in this context, the implicit instructions that you gave to the fire department was, please put out the fire. Mm-hmm. This is called a continuation. Okay. The tricky part is figuring out how to deal with your continuation in a new environment. So the environments change, right? But when you got your continuation. And so this led to an early functional style of programming called continuation passing style. So for an example of continuation passing style, if we look at this code right here, this is typically how we would probably solve Pythagoras's famous algorithm, right? Right. So you have an add function, pretty straightforward. You have a square function. Yep. And then you add the square of x to the square of y, and you've got your solution. Okay. Yep. Now in continuation passing style, what you're doing is you're telling it what to do next, right? You're passing in some function that's like, okay, after you're done doing this, then do this, right?
Right.
So if we look at the difference between add CPS and add, you'll notice you've got your x and your y, but then you're getting back a function that's going to take a third argument, and that's what to do next, right? Mm-hmm. So here we're going to add x and y, and then we're going to call, this function with this as the argument. The add xy is the argument.
Right. So you end up with very deeply nested code because each layer down has to be passed in the function that it has to call next.
Yes. So look how nasty this gets when you actually want to put this all together. Right? I mean, you've got this, pyramid of doom going, and I mean, I don't know about you, but this took me probably a half an hour to really, just trace my way through the code. I mean, it was it was crazy. But the awesome thing about this is you do have you've effectively got lazy code. Mm-hmm. So just to run the proof of this, because one might think that in here you're actually when I call this function with 1 and 2, say. At first, when I looked at this, I thought this was going to run. It was just going to execute. Right. So I had to prove it to myself that it doesn't. Okay. So let's comment this out. Okay. So what we're going to do is suspended test, right? Is going to be equal to test lazy. Test lazy is essentially that same code that we saw up in add, but with this replaced. Okay. Now, if I call this, if I clear and I run this, I don't get the you called Sam, right? Right. So that's proof that it didn't run. And that's another, major benefit of observables is you get this lazy behavior. And we'll cover hot and cold observables a little bit later in the talk, but that is sort of the difference between lazy and eager. Yeah. Okay, great. Let's see. So fortunately, continuation passing style, had some, very compelling and powerful reasons to use it. Lazy being one of them. Mm-hmm. Being able to return early was another. But eventually, people realized that they could package this, bottle this thing up into a monad, and this monad essentially became the observable when some very smart guys at Microsoft. Eric Meyer being kind of the principal character in this. Mm-hmm. He was the author of the link library, the LINQ for.
Oh, right. Yeah. Yeah, for .NET.
So, he had all these powerful operators, and one day he realized that the iterator pattern, if you inverted it, essentially becomes this observable. And when you put those operators together with the observable concept, you have like one of the world's most powerful monads.
Yeah.
And if you want to see kind of a mind-bending but absolutely fascinating video of him talking to Brian Beckman and the two of them just hashing out how to invert this iterable into an observable on a whiteboard, there's a video link in the repo. It's definitely an amazing video. It took me 3 cups of coffee and probably 3 times viewing it to fully get it, but it's pretty amazing. Okay. So, so let's just hammer this home. In the iterable pattern, the consumer calls the producer, it returns an iterator.
Right.
The consumer is in charge of pulling the next value out of the iterator. In the observable pattern, you pass in an observer and it pushes the next value to the consumer through the observable. Okay. Let's see. Items versus collection. Yeah, we covered that. Okay. All right. So we looked at the observables from scratch. Let's look at.
Let's go back to some of those real quick. I want to see some of those in action to kind of get a better feel for what's really happening with those observables from scratch.
Okay, so let's look at the ones that deal with time. Okay, so we got our timeout right here. So let's see. So right here, we're going to create an observable, right?
Right.
So this isn't going to do any work when we do this, right? We're teeing it up. We're saying timeout 2000 milliseconds, right?
Oh, right, because this returns the function that, does that timeout function return another function or the observable object?
Okay, well, let's see. All right. So it returns an object with a subscribe method.
Oh, right. Okay. Sorry. The syntax. I'm honestly still getting used to the arrow syntax, and without the parentheses around the word time, I forget that that's a parameter to the function.
Right. This is a parameter.
Yeah.
Okay. That gets, plugged in here.
Yeah. So that returns. So that's the time in milliseconds that you're passing in. You're returning the observable object.
Yes.
With the subscribe method, or is that the right word, observable object, or is that
an observable or an observable object? Yeah, they're one and the same. So
gotcha.
An observer or an observable, I should say,
right,
is an object with a subscribe method.
Yes.
Okay. Now the subscribe method takes an observer,
right,
and returns
the disposable
object.
Gotcha. Okay. So you're calling on line 40, you're calling the timeout method, which creates the observable with the number of milliseconds for the timeout.
Mm-hmm.
And then later down below, you're going to call the observable and pass in an observer object that has those 3 methods.
Right here. Right.
Okay.
So now we're pulling the pin, right? We haven't done any work here.
Right.
We just initialized things. Now, when we call subscribe, that's when we're going to do, our work, and we pass in the observer and we tell it what to do with the results of what we've just done.
So on line 50, why are you calling console.log right there? Is that going to log the actual output, or is that going to log the observer?
Well, remember what we get back when we.
That's going to log the disposable object.
Exactly. So let's run this. Okay. So there's other examples down here,
right.
But this is our disposable object that we got back, right? That's the result of this log. Okay.
Yep.
And then after 2000 milliseconds, it printed next and complete. And let's look at the code, right? So right here, we passed in this observer. Okay. All this observer is going to do is take an argument here and log it to the screen. So within this code right here, we took the observer that was passed in here, and we called its onNext, and we sent it next, which is shows up there. Okay. And then we called onComplete. but we didn't pass it anything, right? But this observer says, when you call me, I'm going to log complete. So that's why we got this here.
Right.
Now, just to show you how powerful a few lines of code can be, right? We've written an observable from scratch, okay? This is like, I don't know, 10 lines of code.
Yeah.
So let's look at this. Let's look at this guy right here, this get JSON, right? It's going to take a URL and it's going to call it. And then whatever it gets back, it's going to pass on next to the observer the JSON that is returned, and then on complete. Now, if I was really doing this right, I would probably check the status of the return. And if there was an error, if I got 404 or something, I would want to call on error.
Right.
And pass whatever information was important. But this is just kind of, down and dirty. So what I did right here was I took the Flickr API, the JSONP API, and we're going to replace the term in the right spot of this URL. And then I'm going to call get JSON, search Flickr with the term dog. Okay. Now, again, it hasn't done any work. It's just teed this guy up because it's going to return an observable object with a subscribe method, right?
Right. And we're starting to see a little bit of composition here by having that search Flickr function, which returns the URL that gets passed into the get JSON, which returns the observable. Right.
So, so the rest of the bits here. Let's see. What did I do? Observable console. Well, anyways, here's what this looks like when we run it. Essentially, we're getting back from the API a bunch of random pictures of dogs from Flickr.
Nice.
And, it's not a lot of code for something that gets you some impressive, results.
Yeah,
I would argue. So this repo, all of these bins are linked in the repo. So feel free to go ahead and play around with this stuff. In this section right here, notice we are not calling in any libraries. These are observables from scratch.
Right.
Okay. Right. So what I do want to get you into, though, is an example using reactive extensions, because it's just a much more vetted, robust, battle-tested library. And there's no reason to do all this stuff from scratch, but just know that you can do it and know that it's not a lot of code. That's the main take home here, is that under the hood, there's not a whole lot going on. Let's see. This is kind of a fun example using reactive extensions. And by the way, at JSBin, you can pull in reactive extensions right here.
Very nice.
You probably want to just start with this for starters. It's kind of the kitchen sink. But when you get deeper into this, there's smaller libraries like RX Lite that probably have the things that you need and nothing else. So what we're going to do now is we're going to compose some streams together, okay? And this is the way you kind of want to think about things. In this example, I wanted to do a drag example. I wanted to be able to take this and then drag it around the screen. And then when I mouse up, it stops and it just stays there, right? So we want to think about what streams we have and what streams we want, okay?
Right.
So ultimately, we want mouse move streams so that we can tell this particular sprite where it should be repositioned.
Yep.
But we also, when I'm not dragging, we don't want it to move, right? So we've got this start stream, which is really a mouse down event. It's only going to be one event, right?
Yep.
But it's infinite. All of these DOM events are infinite streams. They're kind of what we would call hot observables. Regardless of whether or not we're listening to them, they're constantly spitting out information.
Okay, I see. So that's a hot observable, you said?
Yeah.
Versus a cold observable is something that just spits out information once.
Yeah, when we subscribe to it, okay?
Right.
It starts doing work when you subscribe to it. Otherwise, it's lazy and just sits there and it's happy to do nothing.
Yep.
Okay. So here's our mouse move streams. This is the one that we really want.
Mm-hmm.
And then here's our stop stream. This is the stop event that we're looking for to stop, listening to mouse moves.
Right. So you're really managing the state of the application based on the events that you're receiving from the observable at this point. Because frankly, I've written drag and drop code like this a dozen times using events and object-oriented, mutatable states, and it gets really nasty really fast. So
absolutely,
I'm very interested in seeing how all this comes together.
Okay, so this is the entire code right here, 29 lines. Okay.
Wow.
All right. So here we get the element.
Yep.
Here's a couple helper functions, right? This is the one that's going to move our sprite around. This is probably could be optimized here by pulling that out. But anyways, now here's where the magic happens, okay? Here's where we're telling it what we want, okay? Sprite drags.
Yeah.
That's what we want to get. So we've got this start stream, which we made right here from event, okay? We're going to take the stream of events that come out of that, and we're going to map them.
Mm-hmm.
Okay, so that's going to be a mouse down. It's only going to be one, but we're going to use map to get this done. And then we're going to trigger our mouse moves. And this is a really cool little operator right here called take until the stop stream.
Ah.
So we've declared exactly what we want. All right. Now this little concat all is what we call a flattening strategy. Because if you recall from our last talk, when we looked at the implementation of a monad's map,
mm-hmm.
It took its value out, it created a new monad of the same type, transformed the value somehow, and put it back in that new monad and returned that, right?
Right.
So anytime we see map, we are adding a second or a new dimension to this. So this, right. At this point, we've got an observable of observables, okay? And so we need some way of flattening that all down at the end of the day so that we've got one observable stream. And there's really three major strategies for doing this, okay? You've got a concatenation in which things, let me show you kind of a visual of what that looks like. Let's see. Where did I put that? Oh, maybe it didn't make. Oh, yeah, it didn't format right. I'm going to have to reformat that.
Okay, sure.
All right, so in concatenation, you're adding one thing after another.
Yep.
In fact, let's look at this marble diagram. Okay, these are kind of fun. This is a good way to visualize events. So this would be an event, another event, another event. The line represents time, okay?
Right.
So this is left to right, top to bottom. So this is one event stream with this
mm-hmm.
arrow right here. And this is another event stream right here, okay?
Mm-hmm.
So when you concatenate them, you get the entire first event stream until it stops right here at this crossbar.
Yep.
And then you tack on the second event stream.
Yeah, so it's like concatenating two arrays.
Exactly.
The first array concat, the second array, you just get literally the first one and second one shoved together into a new array.
Exactly. Now, let's go look at merge. Merge are like cars on a highway.
Yeah.
Right? So when you have a merge situation, this car,
mm-hmm.
Moves into this lane, this car moves into this lane, this car moves into this lane, and then this car moves in there, right? They all just kind of come together in the order that they relatively showed up in overtime. So that's a merge. Not too terribly complex.
Yep.
Now, the third type is what we would call switch latest. Switch latest is interesting when you have an autocomplete box because oftentimes switch latest is a pretty handy flattening strategy. When you're doing an autocomplete box, and I have an example, I think. Yeah, okay. So here's an autocomplete box in 55 lines of code.
Mm-hmm.
Not bad. So if I go in here and I type in.
Nice.
All that is really essentially right here. That's the code.
Right.
So we've got some key press streams. We throttle it just for performance sake. And then we map that, once we get a key event, a key press event, we call this searches function with the text box value, which is the contents here. If it fails, we retry 3 times, which is kind of nice. If that request fails. And then we call switch latest. And the reason why we call switch latest is if I jam on this thing and I type TRMIATOR, which isn't proper spelling, there's no guarantee that the second request will come back after the first request.
Right.
So as soon as things come back, you want to just grab the latest results and unsubscribe from the other streams, because you're producing a stream for every key press, right?
Right. And that's a problem that I've run into in the past, where I make 3 or 4 requests to do something. The second one gets there first. The first one gets there second, and things are suddenly out of order and causing me lots of problems. I have a very specific scenario where I have that happen in one of my applications, and the workaround to prevent that was nightmarish.
Right, and that's why they created this little operator here. It's useful in a lot of situations. So again, I want to hammer this home, right? We see a map here. That means we've gone from 1 dimension here to 2 dimensions here,
right?
Okay? So we need to flatten that out, and switch latest is the right one to use here.
So switch latest is just going to say, okay, I know I've sent 4 of these requests out, but I only care about the 4th one because the other 3 are now irrelevant.
Well, just give me the latest information, whatever. So these streams, when I type A, B, C, right? The first thing to go out is A, the second thing to go out is A, B, and the third thing is A, B, C, right? So the latest is A, B, C. That's the latest request, right? So if, A comes back first, great, let's put it on screen. If A, B, C comes back first, great, let's just throw away A and A, B, right? That's what this does.
Right, but if A comes back, it'll show the results for that. And then if ABC comes back, it'll show the results for that, but then throw out AB.
Exactly. If AB hasn't returned, just ignore it. Just unsubscribe and we're done. Abort.
Nice. Yes.
Okay.
Yeah.
All that's taken care of for you under the hood. Okay. So one thing I want to show here is this is how you would create an observable from scratch using Rx. There's a lot of these little helper factories, like from event, which you can use when they've got from promise, from array. There's tons of factory methods, and I'll show you where to find those. But if you have to do it from scratch, this is how you do it. You call Rx observable create, and remember, when you're creating observable, it is a object with a subscribe function. So here we're going to kind of go in an anonymous Lambda function, right? So Rx is going to handle making that object for us under the covers. Let me just format this well. Okay, so we're passing in a function that takes an observer, okay, and it knows how to do its business and call the observer with the on next and the on completed. Here we're checking to see if this was canceled or not, and before we kind of do this call. And then we want to return a disposal function. And here it can be anonymous because, again, Rx is going to take this and put it into a disposable object for us. Okay? So a subtle distinction, but when you look at the stuff that we rolled from scratch versus using observables create, these are good things to keep in mind, right?
Yeah, it simplifies things for us a little bit. It injects those functions that we are returning into the correct object structure so that we don't have to remember the object structure. Exactly.
So go play with this example. Pretty straightforward. One of the operators I wanted to touch on, which I had you guys work on in the first exercise with Hussein's tutorial, is zip. And zip is something that has really, you're typically not going to use it on arrays. There's not a whole lot of use cases for that. However, I want to point out that a lot of this is coordinating these asynchronous things, and Zip is very helpful when it comes to coordinating multiple network requests.
Okay.
So here's a marble diagram for that. Oh, and by the way, there are some examples in this, and this is the Rx manual right here, which I've linked to in the repo. It's extremely good. You could chew through it in probably a day, and it's loaded with really helpful marble diagrams and explanations and code that you can play with too. They've got all these bins down here with example code. All right, so let's see. Yeah.
So Zip is really taking items from the first stream or array and matching them up with items by position from the second one.
Exactly. You're taking two things and putting them together, but in order and preserving that order. So let's look at that real quick. Just so you've got one from this stream and A from this stream. And as soon as you've got a pair, boom. Right. So you can think of asynchronous issues in where you've got a network request out to, maybe likes and a network request out to some other, resource information about a user. And as soon as they get back, then we can render our page, right?
Yeah.
And they do this over and over again. And once this comes in, boom, we got 3C. So they can come in different orders, as you can see, but the key thing is this is how you coordinate those efforts. Okay.
Nice. Yeah, I can see a lot of scenarios with network requests for retrieving multiple bits of information about the same resource. How that would be really useful. Your example of social network is good. If you're displaying a list of people and each item in that list needs to have number of follows and number of followers, then you may make multiple requests for each item being displayed, and you would want to make sure they get displayed in the right place on the screen. That could be a really easy way of making that happen.
Yeah, it's all about coordination.
Yeah.
So I want to point this out. When we get into the operators, let's see, Rx operators. Okay. So this is in the repos documentation. You've got all of these methods that are static, and then you've got instance methods right here. And you'll see, oftentimes you'll see like a concat, and then you'll see a concat all.
Right.
And then you'll see a concat map, okay? So concat is just like your good old-fashioned array concat, right? You have an instance of an array, and then you have something you want to concat to it. So you call the array.concat, and you pass in whatever you want to concat, and you're done. Concat all works on an observable of observables, a two-dimensional observable, right?
Okay.
So it's like a stream of streams, and that will concatenate that stream together. And oftentimes what you'll find yourself doing is you'll map, and then you'll pick some sort of flattening strategy. Okay. So this, in essence, becomes your equivalent of chain and Fantasyland perspective. Okay. What you're doing is you're going to map, and then you're going to flatten it. Right.
Right.
So this is just one operator, so you don't have to keep doing that map concat all, map concat all, map concat all. All you have to do here is just concat and map.
Nice.
There's also a flat map, which does the same thing, except for instead of concatenation, it uses a merge. Okay. And some of these guys have aliases. Let me see what this probably has an alias too. Yeah, select concat. So, I mean, there's multiple ways to call these things. All right. So we've got 10 minutes left. Should we maybe open it up to some questions? Or?
Yeah, definitely. There's a couple of questions below. I do have one question that I want to ask. We talked earlier about how observables can eliminate the problem of memory leaks. And that's a huge problem that I've run into personally with Backbone JS in the past. I wrote an entire library just around managing events and memory in Backbone.
So,
how do observables really do that? How do they prevent memory leaks?
okay, so again, going back to that responsibility, once we shift the responsibility from the consumer to the producer, then we can use operators like take until, okay, to declaratively say, look, because that's typically how the async world operates. You go, someone opens up a dialogue and, types in a form and presses send, but then clicks on the cancel button,
right,
and that screen goes away. You want to be able to fire off requests to the network until someone presses the cancel button. Right. It's a much cleaner way of thinking about things.
Right.
You don't have to go, oh God, they just clicked cancel button. Now I've got to go unhook all my event listeners. Right. So it's like, you're telling the producer up front, this is the conditions under which I want everything to be cleaned up.
And is it through that dispose method that the disposable that's returned from the observable?
Yeah. So that's how the observable knows how to clean up.
Okay.
And the reason why that dispose method is returned to you in a disposable is because even though the observable knows when you want it to clean up, you as the consumer might decide at some point, whoa, I don't want any more data.
Right.
There are use cases where that happens, right?
Yeah.
So you need some way of saying, I don't want any more data. So it's there, just like you would traditionally unhook event handlers. You just call dispose. Because wrapped up in dispose, let's go look at one of those. Wrapped up, let's look at the event listener, okay? So here we're making an observable out of a DOM event, right? In this dispose method, we know how to say target remove event listener, right?
Yeah.
So, under the hood, we're doing the same stuff.
Right.
It's just we're passing the responsibility over to the producer.
That makes sense. And actually the little library that I created for Backbone pretty much did this. It didn't do it through this formal of a pattern, but it essentially inverted the responsibility so that the object that triggered the events would be able to dispose of all of the event handlers.
Right. Exactly. Yeah. It was a very, or still is a very slick library, by the way.
Thank you.
But if I'm going to share my screen one more time, or do we have some questions I can answer?
Yeah, we have a couple of questions below. I'd like to get to those.
Okay, let's do that.
So the first question from Andrew he asks, are observables more appropriate on the client side because you might want to throw things away, like AJAX responses?
Yeah, typically you're going to find more uses for it on the front end.
Okay.
But it works for anything asynchronous or concurrent.
So you'd be able to, you wouldn't have an issue going into like Node.js on the back end and writing an observable to do a call to MongoDB or RabbitMQ or something like that.
There's even factories to interface with Node. So
nice.
Yeah, it works with Node.
Very nice. Second question then from Joshua. Could you talk about the purity of the functions you've shown? Some of them seem to have side effects, if I understand them correctly. Also, is it fair to say that monads are abstractions for impure functions? So perhaps observables are allowed to have side effects since they are monads?
Well, I'm glad they're paying attention because there were some dirty things going on in there. Most of it was just me being lazy and it was convenient. So,
right.
But yeah, I mean, monads are monads. Observables are interesting because, they take these sort of chunks of code and they modularize them. They isolate, pieces from other pieces. And it's this issue of time. We're always comfortable with, 1, 2, 3 dimensions. And then we get to the fourth dimension and it's like, what does this look like? Right. So things over time kind of blow our minds because it's like a go-to, I mean, you're going sequentially through your code, and then suddenly, boom, you have to go back, and deal with some other code. I don't know if that answers the question, but but yeah, there were some impure things going on in some of those examples, but the observable itself is definitely monadic and pure.
Right. Third question, can you flat map more than one level deep of nested streams? So if you have a stream of streams, would flat map account for the third, fourth, fifth level? Or do you have to do...
No, it's one at a time, but
Okay.
you can just, however many times
you'd
you
have
map it, you can concat all. And,
you would have to know how deep your structure is, and you would have to flat map the flat map.
Right.
Gotcha.
Well, flat map, okay, so flat map does it all in one, right? So if you map, you have to concat or merge or switch latest or whatever it is.
Well, that's the question. If you have three levels deep in your nesting of streams, would flat map head down to that third level and bring it all the way back up, or would it only get the second level deep?
Okay, so with flat map, what happens is it does the map and creates another dimension, and then it flattens it. So it's not, you wouldn't do, I mean, you could do flat map 3 times over and over again, but flat map, you get both your map and your merge.
Okay.
So, if you called map, then map, then map, then you'd have to go all merge, merge, merge. If you call flat map, you've mapped and then you've merged.
Okay, I think that's making sense. Hopefully that answers your question, Stefan. At this point, I don't see any other questions in the list. There was some additional questions in the chat. Somebody had asked about how this related to async await. What about, let's see, that was Mauro. What about async await compared to observables? Is there any relationship? Because I know async await it's future syntax in JavaScript, something that's being proposed, but it's meant to deal with asynchronous code to make it look synchronous. Is there a relationship between observable and async await?
There probably is. I'm not an authority on that particular syntax. I'm aware of it.
Okay.
But there is a proposal to make an observable part of some future version of JavaScript. And Jafar Hussain is on the committee, and I know he's kind of pushing hard for that. So.
Okay. Nice. All right. No more questions at this point, as far as I can tell. This is definitely looking promising, to use an overloaded word. But no, this is really good. I'm starting to see the value of what an observable could do for me, especially creating a consistent API around events. I can already see how I could build a library to take data out of a backbone model and push that into DOM elements really easily, and not have a lot of the worry and concern that I've often had with the way I manage and manipulate different types of DOM elements. Whether it's a div or an input box or a select box or a radio button, it would be really easy to create an observable adapter around the different types of elements, and that could be something pretty darn useful and pretty darn cool for a lot of the applications that I'm still building in Backbone.
Right, and I want to point out that a lot of the operators that you'll find in Rx are in this sort of domain language of arrays, right? Because you can take any kind of operator that you use on an array, and you can use it on an observable. It's just the difference is the observable is going to have data coming in over time. So that's why, if you get comfortable with arrays, it's not a whole lot of work to adapt that knowledge to an observable. So
the real difference is just knowing the pattern of, well, you have an observable and you have a disposable, and the observable takes in an observer, which has those 3 methods: next, complete, and error. And then you have the dispose so that it can get cleaned up at some point in the future. Exactly.
That's it. You got it. You got it nailed right there.
Excellent. Well, I do want to say thank you once again, Chet, for enlightening us with more functional JavaScript. There's there's a tremendous amount of value in everything that you've brought to us. And I really do appreciate your time and appreciate all of the effort in putting together that repository with such a phenomenal list of resources to continue our own education from. So thank you once again for doing that and for being here.
You're welcome. Thank you. My pleasure.
All right. Thank you very much, everyone, and we'll see you later.